So today the student will be able to use the definition of an inverse in order to find inverse relations and functions. First, you need to know what an inverse is. The inverse of a relation is the set of ordered pairs obtained by switching the coordinates. Whoops, I didn't mean to turn that on. Switching the coordinates of each ordered pair in the relation. So x becomes y and y becomes x. If the relation is not a function, or if the relation is a function, you can rewrite the inverse of f of x as f of negative 1x. This negative 1 does not indicate a reciprocal. And what I mean by that is if you saw like a fraction where you had 4x negative 1, y 3, x 2. The first thing we would do is we would move this x negative 1 down because you can't have a negative 1 exponent. But this negative 1 is not talking about an exponent situation. It's just a notation that is commonly used so that you know you have an inverse of something else. So when comparing two functions, if you want to know the inverse of f of x, the nickname of that function is f, right? So if we put it in a word problem, everybody would know if we said f, which function we're talking about. When you talk about f's inverse, you don't want to give it a brand new nickname. You want to keep it f because that's where it came from. But this negative 1 just does or denotes that we're giving it that it is the same function, but now it's the inverse of that function, so it is changed. So again, the negative 1 is not really a negative 1 exponent. Instead, it's just a notation that is commonly known to represent the inverse, not an exponent. Okay, and remember when you have function notation, this x does not mean you're multiplying by an x. It just means that the function that we are writing has x variables in it. We're not using y's, we're not using p's, we're not using q's, we're using x's. Okay, so there's your definition. Okay, so for example, if I have f of x is x plus 1, and I tell you that, oh, sorry, that is a typo. This should say f of x is x squared plus 1. I'm sorry. Okay, x squared plus 1 is this graph. So this graph is my function f. Okay, when I take the inverse of f of x, I end up with this equation, the square root of x minus 1. So this graph here is the inverse of f. A couple things you'll notice. The notes we're about to take, I'm going to show you how to mathematically go from this equation to this equation, how to find the inverse. But I want you to notice some things on the graph first. So if you graph x squared plus 1, you end up with this parabola shape. If you type square root of x minus 1, you end up with this shape here, which is a square root graph. The thing about inverses in their graphs is if you folded your paper on the line y equals x. So y equals x cuts through the graph diagonally, and if you folded your paper on that diagonal, your original function will then graph onto your inverse. So if you can imagine picking up your paper and folding it right there, these two U shapes or parabola type shapes would fall on each other, okay? If I didn't give you the inverse and I just gave you this first parabola here, you could find the inverse picture by folding on that diagonal line. Okay, so that's just a couple things I want you to see or to kind of think about before we move on. The other thing I want you to think about is we talked about ordered pairs. We talked about switching the coordinates of ordered pairs. So let's test that for a second, okay? Let's just say that I pick an ordered pair off of our original f of x graph. Well, this is an ordered pair on that graph. And this is the ordered pair where x is 2 and y is 1, 2, 3, 4, 5, 6. According to the definition, if I switch the coordinates, so if I switch the coordinates instead of 2, 6, I have 6, 2. That should be a point on the inverse graph. So let's plot the point 6, 2. X is 6, y is 2. And this is not a perfectly drawn graph. That is a point on the inverse, okay? If I picked another point on my original, let's go, again, it's not perfect, so we're going to go close here. This is at 0, 1. So if I switch it, I should find the point 1, 0, which is true. So if you see the graph, you can think of the coordinates being switched, and that's how you get the graph of the other. The equation I'm about to show you how to find. But for the graph, you need to think switching coordinates. The x becomes the y, and the y becomes the x, and that's how you find the coordinates of the inverse. So if you're given the original, you can find the inverse by switching the coordinates, okay? But now, how do you find the equation? So how do you go from this equation to this equation? So that's what I'm going to show you now. If f of x equals 3x plus 1, I want to find the inverse. Here are your steps. So to find the inverse from an equation, you're going to follow these steps every time. First, write f of x as y. So you're going to change your function notation, which is really just the nickname we gave it. Instead of f of x equals, we're going to write y equals 3x plus 1. Second, you're going to exchange the x and the y. So we're going to change them just like we talked about, switching the coordinates. We're going to switch the x and y. So I'm going to take y away and make it x. I'm going to take x away and make it y. Then last, I'm going to solve for y. So if I can get y by itself, if I solve for y, then I will know the inverse function, or the inverse relationship. In order to get y, I have to minus 1, x minus 1, 3y. To get rid of the 3, I divide. So divide everything. So I have y equals x minus 1 over 3. Okay, but we need to rename it because remember, this is the inverse. So I just found the inverse, but I need to designate that it's the inverse of this function we started with. So I'm going to rename it with the nickname f, but I need to say it's the inverse, and we're using x variables, x minus 1 over 3. Okay, so that's how you find the inverse function. So now you know how we get from the original equation to the new equation, and you also know how to look at the graphs. They're going to flip over that y equals x. Okay, so now let's just practice that. Number 2, find the inverse of g of x equals x squared plus 2. So first, instead of g of x, I'm going to write y equals. Then I'm going to change the order. So I'm going to switch my coordinates. So the y becomes x and the x becomes y. Okay. Now I need to solve for y. So in order to get y by itself, we're going to move this 2 first. So minus 2, because the opposite of plus. So x minus 2 equals y squared. To undo a squared, you have to take the square root. So the square root will cancel the squared and leave you just y, which is what I was trying to get. But then I have to square root the whole other side. So y equals the square root of x minus 2. But I need to rewrite it because we need to go back to the fact that we started with this function we nicknamed g. Well, now I have g. The inverse of g has x variables and is the equation x minus 2. Oops. Okay. Find the inverse of the function f of x equals 5x minus 1. So y equals 5x minus 1. Change the order. Solve for y. So I end up with x plus 1 over 5 equals y. But I need to go back to the name of my function. So I'm really using the function f. Its inverse has x variables and is the equation x plus 1 all divided by 5. Okay, next one. I'm going to change p of x to y equals. I'm going to change the coordinates. So y becomes x. X becomes y. And now I'm going to solve for y. Okay, this one has a lot going on. So to solve for y is inside of the parentheses, and I can't touch what's inside the parentheses until I get rid of everything that's outside of it. So I need to get rid of this 1/2 first. 1/2 is kind of like dividing by 2. So the opposite of that is going to be to multiply by 2, and that will cancel the 1/2. But I need to do that to the other side also. So I have 2x equals. Now nothing else is outside the parentheses, so I don't have to write them anymore. Now minus 3. So 2x minus 3 equals negative 2y divided by negative 2. So I have 2x minus 3 divided by negative 2 equals y. But I don't want to leave it as equals y because I want to say that it came from this p function. So the function I nicknamed p has an inverse made of x variables and is equal to 2x minus 3 divided by negative 2. Okay. What is the inverse of this function? M. So I'm going to make it y equals first. X plus 2 squared minus 5. Change the letters. Okay, now again, there's parentheses, so get rid of the stuff that's outside first. So first I'm going to get rid of this minus 5 by adding x plus 5 equals y plus 2 squared. Now I'm going to get rid of the squared. So as you square root to cancel the squared. So I have square root x plus 5 equals what's left inside is y plus 2 minus the 2. So you have the square root of x plus 5, then minus 2 is equal to the y. So that minus 2 is not a part of the square root because we square rooted first. Okay, but I don't want to leave it as y because I want to say that really this came from the function called m. So I can say the inverse of m is made up of x variables and is the equation x plus 5 minus 2. Okay, our last question is a little weird. It says our f equals x squared plus 2 and g, which equals negative x squared minus 2, are those inverses? Well, you could find the inverse of f and find the inverse of g and see if it gave you the equation that you started with. Or here's kind of a new rule, which is why we learned how to do composite functions before. If f of g of x is equal to g of f of x, then they are inverses. But if that is not equal, then they are not inverses. So if f of g of x is not the same answer as g of f of x, then they are not inverses. So think back to last week when we did composite functions, and let's see what we get. So f of g of x means I'm going to put the g function inside of the f function. So I'm going to start with my f function, take the x out, squared plus 2, and I'm going to put g inside where x used to be. So negative x squared minus 2. Okay, first I need to square that. So I have negative x squared minus 2 times itself, and then this plus 2 is hanging out at the end. Negative x squared times negative x squared is positive x4. Negative x squared times negative 2 is positive 2x squared. Negative 2 times negative x squared is positive 2x squared. Negative 2 times negative 2 is positive 4. I'm going to bring this plus 2 down later, okay? I'm going to combine like terms. So x4 plus 4x squared plus, 4. And now bring our plus 2. Now we can combine those. So f of g of x equals x4 plus 4x squared plus 6. Okay, now I need to see if g of f of x is going to give us the same equation or not. So I'm going to start with g, negative, leave a parentheses where x used to be, squared, minus 2. I'm going to put the f function inside of that. And the f function is x squared plus 2. Okay, now I'm going to leave this negative and this minus 2 to come down at the end. But first I'm going to figure out what x squared plus 2 squared is. So x squared times x squared is x4. X squared times 2 is 2x squared. 2 times x squared, 2x squared. 2 times 2 is 4. Combine your like terms. So x4 plus 4x squared plus 4. Okay, now all of that has this negative in front. So it's really negative 1 times all of that. And then the minus 2 is in the back. So negative 1 times x4 is negative 1x4. Negative 1 times 4x2 is negative 4x squared. And negative 1 times 4 is minus 4. Bring down your minus 2 and combine those. So you have negative 1x4 minus 4x squared minus 6. So g of f of x is equal to that. So is this equal to that? So is f of g of x, x4 plus 4x squared plus 6, equal to negative 1x4 minus 4x squared minus 6? Those are not equal. So no, these are not inverses of each other. And that's it.